Okay, all right, we're now recording. All right, so welcome back. Hope you had a good break. And we only have 7 weeks left. It's going to be action-packed somewhat, okay, including an exam this coming Thursday, as I tried to mention to you either day or a couple of days ago, just to warn you, because once you get back to school, you guys say, "Oh man, I got to go back to school" and all that stuff. But we only had one section left before the test, 8.5. Okay, so exam this coming Thursday already. It covers chapters 7 and 8. And as you can see, I was pretty much done with everything except for 8.5. I don't have to finish 8.5 today. I was hoping part of the second hour to leave for questions and answers if you want to prepare for the exam. And depending on whether or not Mackenzie and Starr are with us, they could help also. But if they're not there, that's okay. You can stick around and ask me stuff also. Okay. And again, I still have all these buffer days that I haven't used up. Remember at the beginning, I was saying, okay, in case I fall behind, I got these buffer days. So far, I haven't fallen behind. All right. So we've got plenty of time to spare, so to speak, before we have the exam. So we actually have 3 more exams. Okay. So exam this coming Thursday. We will not have the next exam on Thursday the 15th. I'm pretty sure of that. So as to when it is, it may be here. A reminder, we have a flex day on Thursday the 22nd. So we don't meet that day. So whether the test is here or here, we'll see how it goes. But we have plenty of days left over, as you can see. But for now, let's set in stone that we still have the exam here. If I don't do any of chapter 9, I'm still going to be okay. All right. So I may not finish 8.5 today. That's okay. I am finished with everything up to 8.4. All right. So as usual for exams, you turn in chapter 7 and chapter 8, a 70% homework requirement. That's very easy to do considering I do a huge percentage. I mean, some days I end up doing 70% or even more of the homework. So that shouldn't be that hard. All right. So as usual, on Thursday, I'll lecture a very short time. Then questions and answers, break, and then take the test. Okay. On my syllabus, I only promise you the exam for the second hour, but just like the last test and test before that, if you want to start early, that's okay by me. Maybe we're done by 11:30, and then we can start the exam by 11:40. Then you have, maybe even an hour and a half for the exam. Okay. So that's what we're up against. All right. So I'll get started with 8.5. Anybody want to ask a quick question about what's happening before we go on? So it's already April, which means it's accurate to say we're done by next month if you want to make it sound like things are fast. Okay, next month is May and we're done. Okay, so we have 7 weeks, 1, 2, 3, 4, 5, 6, 7. So there's exam 4, Thursday. Exam 5 will not be Thursday the 15th. So not sure about exam 5 and exam 6, but they'll be there. There'll be an exam 5, an exam 6, and a final exam. Okay, so any quick questions before we start today's lesson? All right, seeing and hearing none, then we'll go ahead and get started. Okay, so again, I was going to reserve a major portion of the second hour for questions and answers about anything, and that's optional. So if you don't have any questions, you may just leave, but if you want to stick around and ask either me, myself, or depending if Starr and Mackenzie show up, they may be able to help also. But be ready for that in case you have any questions about chapter 7, chapter 8. So again, 2 chapters, as you know, for every exam. That's the pattern. So 9 and 10, as you can see, 9 and 10, there's not that much. So an exam here, and then 11 and a little bit of 12 and 13, and then we're done with the course. All right. And by the way, some of you are asking, am I scheduled to teach Calc 1 in the fall? No, I'm not. As of now, I'm not scheduled to teach Calc 1. I'm scheduled to teach Calc 2, actually, but you won't be able to take Calc 2 with me unless you take Calc 1 in the summer. I think they offer a Calc 1 in the summer, but I'm not teaching that. So am I teaching Calc 1 in the fall? No, I'm not. I'm teaching Calc 2, right? So the only way you could take me for Calc 2 would be to finish our class and then take Calc 1 in the summer if you feel like being that ambitious and doing all that. Okay. All right. So Last time we had the graphs of the sine and cosine. You're welcome to put that on your cheat sheet. Remember, you're allowed to have one formula sheet, a cheat sheet. Go ahead and put the graph of sine and cosine. If we were meeting face to face, I wouldn't let you allow that. Okay. And now what about the graph of tangent, cotangent, secant, cosecant? So that's the lesson for today. If we don't finish all that today, I still have tomorrow. Okay, but let me focus now on graph of tangent and cotangent. Okay. So the homework is 8.5, 1 to 31 odd, skip 13. Okay, so again, let me show you that for those of you that don't have the book and aren't planning to get it. So you can just look it off. And we had to go up to 31, so there we are. Okay. I'll go ahead and show you quickly the graphs, but then I'll do the derivations of them also. So the topic is the other graphs, page 583, graphs of the tangent and the reciprocal functions, which means tangent, cotangent, secant, cosecant. You're welcome to put these on your cheat sheet. 585, here's tangent and everything involved with it. Okay, but I will give you a little bit of a derivation of it and some information on it about domain, range, blah, 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 blah. And there's the graph. Okay, so tangent. Cotangent, 587. That's what it looks like. You can put that on your cheat sheet. $589, cosecant. Everything you need there. And secant. Bottom of 590. There's everything you need there. And there's a picture of the graph. Okay. Now, if you looked at what they said, the word amplitude does not apply to the other trig functions. And there's a reason for that, although we are going to talk about a multiplication factor. So section 8.5. Graphs of tan x, cotangent x, cosecant x, secant x. We do not use the word amplitude for any of these four functions. Okay. So in some sense, you don't have to worry about the word amplitude. You still have to worry about a multiplication factor, but the word amplitude doesn't apply. Why does it not apply? Well, there's a pretty simple reason. You might recall for sine x and cosine x, we did this before the break. I know that was a long time ago. So it's been a while since you've done this. Okay. So because we are having a test this Thursday, you got to kind of shake the cobwebs out of your, brain and, haven't been in school mode for over a week. For sine and cosine, amplitude, which I abbreviated with amp, was maximum minus minimum divided by 2, right? But if you look at the graphs that I just showed you, which I'll show you very quickly, there is no maximum or minimum. Okay, tangent looks like that. It goes up, 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 and down, 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 down. So there is no maximum, there was no minimum. Same thing for cotangent, page 587, no maximum, no minimum. Same thing for cosecant and secant, okay? No maximum, no minimum. Okay, the cosecant and secant, they seem to have a lot of U shape, upside down U shape, U shape, upside down U shape, and so on. And likewise for secant function, right? In fact, the secant and cosecant look the same. The U shape, upside down U shape, upside down U shape. You might say parabola, but they're officially not parabolas. I know what you mean. So that's why I just say U shape and upside down U shape, but officially they're not parabolas. Okay, we will talk about the period. Okay, okay. So all functions have periods still. And we'll analyze that. Okay, so first let's talk about y equals tangent x. Okay, the text gives you a chart. Okay, they actually give more of a chart than I would do. Let me take care of the curl again. All right. So remember, tangent can be thought of as sine x over cosine x, right? Let me go back to my unit circle definition. And let's get some key points. This is 1, 0, 0, 1, negative 1, 0, 0, negative 1. I'm going to go here, 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 and here. (45 degrees, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay. You might recall they're both radical 2 over 2, except for the sign SIGN. Okay, so let me just put them down. Radical 2 over 2, radical 2 over 2. I'll worry about the SIGN in a moment. Radical 2 over 2, radical 2 over 2. Same thing here. Radical 2 over 2, radical 2 over 2. Same thing here. Radical 2 over 2, radical 2 over 2. So 45 degrees, 135, 225, 315. Okay, quadrant 1, we know x and y are both positive. Quadrant 2, x is negative, y is positive. Quadrant 3, x and y are both negative. Quadrant 4, x is positive, y is negative. Okay, and let me raise this up again for you. You can see everything we have right now. Right. So let me just make a quick table of I'll call it theta now. Theta, tangent theta. I'm actually going to start at negative pi over 2, and there's a reason for that. I'll get to later, but we'll see. All right, now 0. Pi over 4, pi over 2, 3 pi over 4, pi. Okay. All right, so you might recall tangent is y over x. So negative 90 degrees, y, negative 1 divided by 0, that's undefined. I just put a dash, meaning it's undefined. Okay, I'm going to go up to 0. I'll skip this one for a reason, but okay, tangent of 0, y divided by x, 0 divided by 1, 0. Pi over 4, y divided by x, well, they're the same value, so 1. Pi over 2, y divided by x, 1 divided by 0, undefined. 3 pi over 4, y divided by x, radical 2 over 2, divided by negative radical 2 over 2, that's negative 1. How about pi? y divided by x, 0 divided by negative 1, 0. I'm going to go 5 pi over 4. That's over here. Y divided by x, 1. And then 3 pi over 2, y divided by x, undefined. Okay, let me just graph this for the time being so we can see what's going on. Right. So I'm going from where to where? I'm going from negative pi over 2 to 3 pi over 2. So let's see how I can do that. Negative pi over 2, pi over 2, pi, 3 pi over 2, 1, negative 1. Undefined at negative pi over 2, which means I'm going to have an asymptote. Undefined at pi over 2, asymptote. Undefined at 3 pi over 2, asymptote. Okay, well, let's see. 0, 0. Pi over 4, comma 1, asymptote. Okay. And asymptote. It ends up going something like this. Let's continue here. 3 pi over 4, negative 1. 3 pi over 4, negative 1 is like there. Pi, comma 0. 5 pi over 4, 1, undefined. Y equals tangent x. I know I said theta here, but that's to distinguish it from the x coordinate here. But now I'll go back to y equals tan x. Here's the graph. Notice it repeats not every 2 pi. It repeats just from here to here. From pi over 2 to negative pi over 2, which is pi units. Okay, so the period is pi, not 2 pi in general. Okay. So here's the graph of the tangent function. Now, if you just want to get one period, you just go from here to here, from negative pi over 2 to pi over 2. So one period you can go from parenthesis, negative pi over 2, pi over 2. We do not include negative pi over 2, and we do not include pi over 2 because the function values there are undefined. Negative pi over 2, pi over 2, 3 pi over 2, and so on. Okay. The rest of the graph you can copy and paste. Take that basic shape, copy, paste here. There's another one here, another one here, and another one here, and so on. And you end up with what you see in the book. So what's the domain? The domain is not all real numbers. Unlike the sine and cosine function, the domain was all real numbers. We're not allowed to have negative pi over 2, pi over 2, 3 pi over 2, basically odd multiples of pi over 2. So domain is all reals except odd multiples. Odd multiples of pi over 2. that means plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, and so on. Throw those out of the domain. All real numbers except for odd multiples of pi over 2. Okay, now remember for the sine and cosine, how we broke it up into quarters, right? So beginning, ending, halfway, quarter mark, 3/4 mark. Okay. We can do something similar with the tangent function. Notice it's always an increasing function. It always goes up. Okay, tangent x is an increasing function. Always goes up. Unlike the sine, sine goes up and down, cosine goes up and down, not tangent. Tangent is always increasing. So here's the general pattern for the tangent function. Undefined, undefined. Okay, this is 1/4 of the way. Halfway, 3/4 of the way, the full way. Okay, it goes -1, 0, 1. -1, 0, 1. Unless we change it, like the sine and cosine, where we might shrink it, stretch it, compress it, all that stuff. Okay, but the general pattern is undefined, -1, 0, 1, undefined. Okay, so it's undefined. Here's one period, undefined, -1, 0, 1, undefined. Quarter of the way, halfway, 3/4 of the way, full way. Okay, so now I'll show you the entire graph from the text. And you can put this on your cheat sheet. Notice they give us 3 periods. I only gave you these 2. In reality, you can get by with just this 1 period. The standard one that goes from -pi/2 to pi/2. After that, it's just a copy and paste. Copy that, right? Paste, 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 and so on. So the domain is a set of all real numbers other than plus or minus pi/2, 3 pi/2, 5 pi/2, and so on. The range is all real numbers. Just goes as high and as low as you want. Unlike the sine and cosine, the period is pi. And of course, whenever the domain is not included, that automatically becomes an asymptote also. So notice x equals pi/2, 3 pi/2, -pi/2, -3 pi/2. Those are all asymptotes. X-intercepts. Where does it touch x-axis? Well, 0, pi, 2 pi, 3 pi, and so on. So 0 plus or minus pi, plus or minus 2 pi, plus or minus 3 pi. Those are the x-intercepts. Notice amplitude is undefined. Okay, and note the x-intercepts occur midway between consecutive vertical asymptotes. Tangent's an odd function, so its graph is symmetric about the origin. Okay, so we've seen that before, but x-intercepts occur midway. That's the same thing as what I'm saying here. Halfway through the asymptotes, you get a 0. Quarter of the way, -1. 3/4 of the way, +1. And then, of course, we end up changing it to make it harder on us, right? Okay, that's the basic graph of tangent. I'm going to show you the basic graph of cotangent now. Cosine over sine. I'll just use the same unit circle that I had here. Okay. And just so you don't get confused with theta and x, I'll temporarily switch to theta here, but when I go back to the graph, I'll call it x and y. Okay, so theta, cotangent theta. Again, make my table. And let's see, this time I will go like this. And by the way, that's also, well, x over y when I get to it, but yeah, I'll get to it in time. So 0, pi over 4, pi over 2, 3 pi over 4, pi. And for this one, I think that's all I'll do. Cotangent. Now this was the y over the x. This is x over y. Okay, 0. X divided by y. 1 divided by 0. Undefined. Pi over 4. X divided by y. They're the same things. When you divide it, you get 1. Pi over 2. X divided by y. 0 divided by 1. 0. 3 pi over 4 over here, x divided by y, negative radical 2 over 2 divided by positive radical 2 over 2, negative 1. Pi, negative 1 divided by 0, undefined. Okay, I could keep going, but if you keep going, you'll see that it just repeats itself. Let's take a look at the graph of that. So some of it looks similar. I see the undefined. I see the 1, the 0, and the negative 1 again. Pi over 2. There's pi over 4, 3 pi over 4. I'm just not going to write it. Okay. 1, negative 1. Okay. 0, undefined. So, asymptote. I know it's hard to see because I'm trying to draw an asymptote right on the y-axis, but I've already written the y-axis. I'm just moving it over a little. Where else is it undefined? Pi. Asymptote. Halfway, 0. That's exactly like the tangent. But unlike the tangent, pi over 4, 1. That's there. 3 pi over 4, negative 1. So whereas the tangent was an increasing function, cotangent is a decreasing function. The period is again pi. And so we only drew one period here. You drew 2 here. Well, we get all the information we want here, but you could, of course, draw another here and another here, right? So that's what's going to happen there. So the basic 1 period here, however, it's not nice to say negative pi over 2 to pi over 2. Here it's easier to say from 0 to pi. Again, not counting 0, not counting a pi per se. So here's the cotangent function. Domain, we don't allow for 0, pi, 2 pi, and so on. Okay, so domain is all reals except multiples of pi. which means 0 plus or minus pi plus or minus 2 pi, and so on. Okay. Tangent is an increasing function. Cotangent's a decreasing function. Always goes down. Cotangent x is a decreasing function. Again, you should be happy that I'm not making you memorize it, because if we were meeting face to face, I'd make you memorize it. Okay. Now, in case you need this, I'll go ahead and say what I do to my traditional class. If we had met face to face, how would you memorize which is which? Okay. So, and this is real corny. You can write it down or not. Okay, but when you get a tan, like a suntan, you're normally looking up. You look up at the sun, so it's increasing, it's going up. And if you're on a cot, a physical cot, you're lying down, right? A cot is something you lie down, so it goes down. So that was my memory trick. For a tan, you get a tan like a suntan, you look up, so it's always going up. If you're on a cot, if you're lying down on a cot, you're going down, so cotangent goes down. So that's a corny way. Now, of course, you guys don't have to worry about that, but maybe your next teacher is going to make you memorize it. So I memorize tangent is up. When you get a suntan, you look up, so it goes up. Cotangent, if you're on a cot, you lie down, so it goes down. So take it or leave it. And there we go. But it's a decreasing function. Okay. And yeah, what's the breakdown this time? For the cotangent function. So at the 0 mark, quarter of the way, halfway, 3/4 of the way, full way. Again, undefined, 0. But look at tangent, it went -1, 0, 1. What's happening here? 1, 0, -1. It just switches. Okay. And that actually makes sense if it's a decreasing function, right? So it would go down, right? From infinity to 1 to 0 to -1 down to -infinity. Right? Whereas tangent goes the other way at the start of the period, down at -infinity, then it goes up to -1, 0, 1, and it shoots up toward positive infinity. Right. So that's what happens to cotangent. Right. Finally, how do we do the homework problems, right? So y equals a, either tangent or cotangent, b, x minus c plus d, just like we did for the sine and cosine, right? Remember we had before the break and the last quiz we had, right? That time we said amplitude was absolute value of a. We're not going to say the word amplitude, but it's still a multiplication factor. Okay. And we knew that the period was 2 pi over absolute value b, right? And that was a horizontal shift. That was a vertical shift. This stays the same for all of them. In fact, this is horizontal shift, vertical shift. That doesn't change, right? So you start with your basic tangent graph, cotangent graph. You can use mine or you can use the one in the book on your formula sheet, whatever. Okay. Big difference is the period is pi. Okay, so we'll have to analyze the change in one period, that kind of stuff. Okay, but absolute value of a, we're not going to call it amplitude. Instead, it's just a multiplication factor. In some sense, that's the same thing as for the sine and cosine, right? Sine and cosine, they were multiplication factors to stretch or shrink. period. Now for sine and cosine, recall it was 2 pi over b. But the regular tangent and cotangent functions have a period of pi. So it's pi over, strictly speaking, absolute value of b, but there aren't going to be that many problems that you have to worry about the absolute value here. You will have to worry about absolute value here for a, but not for b. This is the same as before. This is the same before. So when written, that's x minus c. So c is your horizontal shift. You should be comfortable with that from a long time ago. And d is the usual vertical shift. All right, so just like before with the sine and cosine, that negative 1, 0, 1 or 1, 0, negative 1, that will change depending on the a. It's basically just a multiplication factor. That b changes the period. So instead of going for tangent, it'd be negative pi over 2 to pi over 2. It'll get changed. Or from 0 to pi, that'll get changed. Okay, so we'll have to adjust accordingly. Okay, for one period, we're always going to start off with 0 in the middle for the tangent. We want 0 to be in the middle there. And I'll show you how to do that now. Okay, so what time is it? I'll do some problems before the break and some after the break. All right, so I think I'll focus just on tangent, cotangent today. All right, so graph each function for one period and show or specify the intercepts and the asymptotes. Okay. So 8.5, page 591, number 1A. Tangent x plus pi over 4. That should be an easy one. Can you think of what's going to happen? Take the regular tangent graph, move it pi over 4 to the left. Pi over 4 to the left, pi over 4 to the left, and so on. Okay, so the original went from negative pi over 2 to pi over 2. Everything else is pretty much going to be the same. So one period. I take that negative pi over 2 to pi over 2. Whoops. And I subtract pi over 4. So negative pi over 2 minus pi over 4, that's negative 3 pi over 4. Pi over 2 minus pi over 4 is pi over 4. And if you find that difficult to do that in your head, you can get a common denominator, right? You can say that's negative 2 pi over 4, and that's going to be 2 pi over 4, right? So negative 2 pi over 4 minus 1 pi over 4, negative 3 pi over 4, and so on. Okay. Everything else pretty much matches the same as before. So how do I do that? Go like this. So negative 3 pi over 4, undefined. Pi over 4, undefined. Tangent, increasing. Halfway, 0. Quarter of the way, -1. 3/4 of the way, +1. Okay, so I'm using this thing here. Undefined, undefined. Quarter of the way, -1. Halfway, 0. 3/4 of the way, 1. It's increasing. It's always going up. So there's the graph. All right, so the intercepts right here. So where's here? That was the origin. I backed up -π/4, right? So -π/4. And then since the period is still pi, it doesn't change, I just tack on a multiple of pi, or we can write k pi. Like that. So period didn't change, we just moved it. So -π/4 plus 0 pi, 1 pi, 2 pi, -1 pi, -2 pi, and so on. Okay, those would be the intercepts. And asymptotes. I could use this one, but I don't use π/4. And again, the period is the same. So k pi. So asymptotes are x equals π/4 plus k pi. And that's that one. Okay, B, and then we'll break. 1b, negative tangent x plus π/4. This is positive tan x plus π/4. Do you recall what happens when you put a minus sign in front? Just get the reflection across the x-axis, mirror image. So this thing's going to bounce over here. This thing's going to bounce over here. So let me just go like this. That's a reflection here, right? And the reflection here, be like so. So the red graph is y equals negative tangent x plus π/4. It almost looks like a cotangent type. It starts to go down. Okay, but we didn't change any of the asymptotes and we didn't change any of the intercepts. So same as the previous one. So intercepts are the same, negative π/4, plus k pi comma 0. And the asymptotes are still x equals π/4 plus k pi. So that doesn't change. All right, and I think it's a good time to break. So we'll take our usual break right now until 12:10ish. Okay. All right, so I'll stop the share, break until 12:10. And yeah, I'll try to give you some time for questions and answers if you have any. That's optional. Right. Okay, everybody, let's pick up where we were. So let me see if I can get the screen back on. Sorry, this can never be fast. Yeah, anybody who came late for attendance, go ahead and put it in the chat and I'll get you. Yeah, because usually once I finish row just after, 11:10, 11:11 or something like that, then I don't like to get it until later. So yeah, anybody that joined, go ahead and put it in the chat. Sorry, this is taking a little bit longer than usual, but meantime, so I do plan to end a little bit early today. I've decided, based on how things are going, I will just stick to the tangent and cotangent. So tomorrow I'll do the graphs of secant and cosecant, and that's still going to be okay. We still have plenty of time. And go from there. I'm getting there. All right, I think I'm finally here. So I'm still going to be on 8.5 tomorrow. I'm pretty sure I won't get past that. So, but that's okay. I've got all these extra days there. I want you to be prepared for the exam. Okay, so again, today I'm going to end class quote unquote early, whatever that means. I'll do some more of the tangent cotangent graphs. Okay, at which point then you can leave if you want to, but if you want to stick around, Star's here, Mackenzie's here. If you want to ask them for help, you kind of got to shake the cobwebs out of your brain. I got to do that too, because that's usually the way it is after a break, right? When you have a break, then you forget stuff. But we got to crank it back up for the stretch run, so to speak. And we have the test here. So Star and Mackenzie, if you wish, if you want to tell the class if you're available to help this week, that's up to you. You can put it in the chat or put it on Canvas announcements, up to you. So so Mackenzie and Star, if you want to do that, if you're there, go ahead. But for the remainder of today, we'll try to reserve some time at the end so you can ask either Star or Mackenzie or me for any questions on chapter 7 and 8 in preparation for this Thursday's test, okay? So again, I'm not going to finish 8.5 today. I still have tomorrow. I still have Wednesday if needs be. And again, if I never get started with any of chapter 9, I think we're still good. We still got all these extra days at the end here. Okay, so I'll lecture a little bit more on tangent, cotangent, and then that'll be it formally. And then whoever wants to stick around and ask questions in preparation for the test, you can stick around, and Mackenzie and Star and I will be around. Okay, and again, if Mackenzie and Star want to add any other extra sessions for helping the rest of you guys out before the test on Thursday, they're free to do so. And it's up to them. I'll leave it to them. Okay. So that was that. Now, let me try to do a problem like number 5. Y equals 1/2 tan pi x over 2. All right, so this does not have any horizontal or vertical shifts. So the A is 1/2, the B is pi over 2. So before we would say amplitude is 1/2. We don't say that, but that is the multiplication factor. Okay. We don't use the language of amplitude though. So multiplication factor. All that does, for the purposes of what we're going to do for the graph, instead of going -1, 1, we're going to go -1/2 to 1/2 or whatever. Okay. If this said a 3, suppose there's a 3 in front. This would be -3, this would be +3. That's all. Same thing for over here. Okay, so the period is not 2 pi divided by b, it's pi divided by b. So that's pi divided by pi over 2. If you divide by a fraction, you multiply by the reciprocal. So pi times 2 over pi equals 2. So the period this time is 2, with 0 being in the middle. Okay. Now remember, for the tangent graph, base 1 period is pi, but you cut it in half and go pi over 2, pi over 2. So what you do is you cut 2 in half. So what's half of 2? Well, 1, right? So you go from -1 to 1 instead. Again, for the tangent, the 0 is in the middle of a period. So the period is pi, you cut it in half, pi over 2 to the left, pi over 2 to the right. We found a period is 2, cut it in half, 1 to the left, 1 to the right. So there we go. Okay, halfway, 3/4 of the way. There's 1, there's -1. Okay, so asymptote, 0. Okay, but normally I would go 1/4 of the way, -1, 3/4 of the way, 1. The multiplication factor is, where'd it go? 1/2. So instead of -1, it's going to be -1/2 on this side, +1/2 on this side. The rest of the graph pretty much stays the same. Like that. Right, so the asymptotes are at x equals 1. Whoops. Lost some ink there. Try this. X equals 1. And then a multiple of 2, basically, because the period is 2 plus 2k. That means x equals 1, 3, 5, 7, -1. It's basically the odd numbers. X equals that. And the intercepts, well, at 0, which I don't have to write, and then multiples of k. So 2k, comma 0. So that's the way that one works. Okay, let me do a cotangent one for you. About 9. Negative cotangent x minus pi over 4. So there's 2 things. Can you tell what the effect of this one is? Move pi over 4 to the right. How about that minus sign? Reflect across the x-axis, right? So move pi over 4 right, and then reflect across x-axis. All right, take the basic cotangent period. Our basic one goes from 0 to pi. So for 1 period, I go from 0 to pi and add pi over 4, which is pi over 4 5 pi over 4. Again, that's just like saying move this over pi over 4 to the right. Okay, so here we go. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Asymptote. Asymptote. Pi over 4, 5 pi over 4. X equals 3 pi over 4. Okay, we're not changing the period. We're not changing the multiplication factor. So for now, at least, I'll do the basic cotangent pattern, which is undefined, 1, 0, -1, undefined. 1, negative. So there we go. 1, 0, -1. Okay, so right now this is positive cotangent x minus pi over 4. Okay, just take the regular cotangent, move it pi over 4 to the right. Okay, now there's a negative. Reflect across the x-axis. So if we look at this part, easy thing is to make the 1 go down to -1. And the -1 bounces up to 1. So that's the graph that I want. Negative cotangent x minus pi over 4. In case you're wondering, yes, you could probably think of that as a tangent type. Looks like it'll be a tangent kind of situation when all is said and done. Okay. All right, I see they actually don't give us too many cotangents. They tend to give us more tangent, but that's a good reason, you know. Tangent is used more often than not. So how about I'll do 11 for you. 1/2 cotangent 2x. Hmm? One half cotangent 2x. A is a half. We don't call it amplitude, but it is a multiplication factor. Period is not 2 pi divided by b, but pi divided by b. Pi divided by 2. So this thing finishes one complete cycle by the time I reach pi over 2. That means one period. Okay, one period is normally from 0 to pi. Now we're only going to go from 0 to pi over 2. So here we go. Pi over 2. X equals pi over 2. X equals 0. It's kind of hard to draw a vertical line right on the y-axis because it's already touching there, but it's okay. So halfway, pi over 4. Half of pi over 2, pi over 4. Half of that would be pi over 8. 2 pi over 8, 3 pi over 8, 4 pi over 8. All right, so one complete period here to here. We're doing cotangent, which is a decreasing function. It's going down. Okay, so normally again, for cotangent at the 0 mark at the beginning, undefined, quarter of the way, 1, halfway, 0, 3/4 of the way, -1, at the end, undefined. Okay, so 1, -1. The multiplication factor, however, is a half. So that means over here, +1/2, 0, 0 times a half is 0. And over here, instead of -1, -1/2. So there we go, 1/2 cotangent 2x. Okay. All right, I was going to do maybe just a couple more and then stop, and then see if anybody has any questions. And if you don't have any questions, you can just leave after that. Okay. Again, ignore any of those that have this mark, which seems to imply use a graphing calculator. Okay, just do it, as it were. Okay, so 15 and 17, those type of problems. Okay. How about I do 15A and then something like 17B or whatever, and maybe that's about it. Okay, 15A. It says tangent x over 4. Think of it as 1/4 x. So A is 1, the coefficient is 1, the multiplication factor is 1, which means you don't change anything. B, however, is 1/4. So the period is pi divided by 1/4. Dividing by 1/4 means multiplying by 4 pi. So this one really spreads out. I won't be able to do it justice on my graph, but we'll just kind of go with it. All right, so tangent looks like there's zeros in the middle, halfway, halfway. So what's half of 4 pi? 2 pi. So I'm not really doing this justice in the picture, but oops, x equals. Right. What's really happening, take this, imagine taking these two asymptotes and moving them out. Okay, just kind of shrink it out 4 times as far, and the graph moves accordingly. So the graph ends up really being way spread out like so. You don't have to draw this if you don't want to. But the new viewing angle is sort of like this. Here's 0. Half of that is pi. Half of that is -pi. Okay, tangent functions increasing, no change. So undefined, -1, 0, 1, undefined. So that stays the same. -1 here, 0, 1, increasing. And there's my graph. I am changing the scale just to fit the paper, sort of. But again, if you think of this, ideally, pretend you take these two lines and spread them out here, and the graph really goes like so, but that wastes too much paper for me, so I'm doing it like that. Okay. I think I'll just do one last one. So I'll be done in a few minutes, at which point you can stick around and ask us questions if you have any, and if not, you can just go ahead and leave. I'm not finished with the section. I didn't do any of the cosecant or secant graphs, so I'll save that for tomorrow. So the new schedule is 8.5 tomorrow also. Okay, and again, exam this coming Thursday. Okay, oh, how about what, 17B? Oh, I'm sorry. Got ahead of myself. Y equals 0.5 tangent pi x plus pi over 3. Once again, I'm not going to use the format that the text does. Okay, I always want the coefficient of x to be 1, so I'll factor that out. 0.5 tangent pi parentheses. So if I factor out the pi, it'll be x plus 1/3, like so. A is 0.5 or 1/2. B is pi. C is negative 1/3. Multiplication factor. Period is pi divided by B. What's that going to be in this particular case, right? Pi divided by B. Pi divided by pi, 1. And then shift 1/3 to the left. Okay. So 1 period. Okay, if you want 0 in the middle, period is 1. Then you have half a unit each way, right? For tangent. 0 in the middle, halfway, halfway. Half of 1 is 1/2. Negative 1/2, 1/2. But because of the shift 1/3 to the left, I have to subtract 1/3. And let me get a common denominator there. This is negative 3/6, positive 3/6, subtract 2/6, which means I have 1 period going from negative 5/6 to 1/6. A little bit awkward there. Okay, that pretty much does it. Well, negative 5/6, I should draw it like this, I guess. More space here. 1/6, 1/6, 2/6, 3/6, 4/6, 5/6. X equals negative 5/6. X equals 1/6. Halfway is right here. Right? Call that 1, call that negative 1. All right, so this is the halfway mark, right? Right over here. So tangent is increasing. Normally you would go undefined negative 1, 0, 1. But again, the multiplication factor is 0.5. So instead of negative 1, it'd be negative 1/2, a quarter of the way. So let me switch to a different color. So quarter mark, 0, 3/4 mark, and then undefined. So that's what we got. All right, folks, that's all I was going to do for today. Let me go ahead and do my focusing thing. And then tomorrow, We will knock off the rest, which involves secant and cosecant, it looks like. Okay, so let me do the focusing thing. Forgot if I did that on the other side also. So let me go that quickly also on that. Okay, so tomorrow secant and cosecant, same section. And then if there's time, I may go ahead and start the next chapter. But after we do the graphs of secant and cosecant, that's basically it for the test. And there's all that. And so let me go back and do the first half also, sorry, in case I forgot to show you this. So this is the first side of the paper that I did today. And there's all that. And a little bit more. Okay, so that pretty much does it. All right, I'm going to stop the share temporarily. Check the chat. Okay, so hopefully, so thank you, Mackenzie. Thank you, Star, for what you have there. Let me see what else I got there, etc. Okay, I guess I have to look at that a little bit later. Okay, so you may leave if you want. If you want to stick around and ask Mackenzie or Star or me anything, you can. And look at the chat for what Star and Mackenzie may have in terms of help for the test. Okay, so that's officially it. You may leave. I'll see you later, but anybody who wants to stick around, you may, and we'll see if anybody has any questions for the rest of today. Okay. Okay, so let's see, we have Jake. So Jake, are you there? If you have any questions, you can go ahead and bring it up. If not.
No, I'm just heading out. Thank you.
Oh, you are heading out. Okay. All right, then Star and Mackenzie, I haven't gotten a chance to see what you put in the chat, but if you have any extra sessions you wanted for the students, you can say, I don't know, if do either of you want to make a comment about that now so I don't have to read it?
Oh yeah, so I will definitely have one. I was thinking probably on Wednesday. I just have to confirm with Lena first to make sure it's okay. And then I was gonna send out a message later today with the exact details.
Oh, okay. Yeah, that sounds good. And Star, you said you're not available maybe, or?
I'm not really sure for right now because I have a lot of big projects I have to get done for some of my classes. But if I find some extra time amidst all that, like either tomorrow or Wednesday, I'll let the students know and
Right.
throw up a
Okay.
quick Zoom meeting.
Yeah, I'll read what you guys have in the chat later, but yeah, that's okay.
Yeah.
I like your picture, Star.
Thank you.
Okay, so yeah, that's pretty much about it for today, folks. So yeah, I'll see you guys next time. Okay, thanks for your help.
See you next
Okay.
time.
All right,
See ya.
bye. Have a good day.